So this here is actually going to be a video to help you study and be ready for the final exam. What I'm going to do is actually go over an example final exam with you. And with this example, I'm going to walk you through all sorts of different questions. Now the final exam that you get, there'll be different numbers, the questions will be jumbled up, but everything will be similar. Again, it might not be the same order, but it'll be very similar. So let's just get right to it. This first question here says find the product. So we have to do something called FOIL. So FOIL is first, outer, inner, last. So I mean, a lot of students, they see the word FOIL and it helps them remember. I kind of also think about it as double distribution. So a couple of different ways to think about this. And I sometimes in some videos, like I said, call it double distribution. And what I mean by that is, all right, so FOIL has you go first times the first. And so that's be the 8x times the 2x. And then O means outer, so 8x times the 3. And so what I mean by double distribution is, you got to distribute the 8x to both, like normal distribution. And then you got to distribute the 7 to both. And that's where it comes into play with the double distribution, because you're distributing two things. So FOIL, first times first, outer times outer, then the inner ones, inner times inner, and then last. So either way you think about it, it's both fine. So 8x and 8x times 2x, 16x squared. 8x times 3, 24x. And then negative 7 times 2x, negative 14x. And then negative times a positive, negative 21. So let's just verify real quick one more time. 8 times 2, 16. 8 times 3, 24. 7 times 2, 14. 7 times 3, 21. And we just got to simplify the middle there to get 16x squared. And those middle two combine to be plus 10x minus 21. All right, so to put the answer in over here, we want to make sure that we put everything correctly. So we have 16x, and then we need to press the exponent to make it 2 plus 10x minus 21. And there you go. All right, next question. This next question here, so this one is solve the equation using the quadratic formula. Now, for this here, it's a quadratic. I mean, quadratics can be solved in many different ways. And you could try factoring, you can try graphing. This one says specifically the quadratic formula. Now, since this, you really don't quite show work with this particular question, you can use any method. But the key for this one here is, this one says type an exact answer using radicals as needed. And then you start to look at that like, oh, wait a minute, I wonder if this is even factorable. And then if you look at it, 8, there's no factors 8 that get you 11. So this one here, we're gonna have to use the quadratic formula, because that is not factorable. And another way to actually test to see if it's factorable or not is we can actually graph it. So let's just get a graph out real quick just to show you. So here's the graph. We did x squared plus 11x plus 8. And then down here, I tried to show you the intercepts. And right there, as soon as we start to see some crazy decimals, something that really can't be written as a fraction or not whole numbers, you start to think, this probably is not really factorable or very nicely factorable. Now these are the estimated answers. Sure, those are the estimated answers. So this will help us verify our answer after we do the quadratic formula. But it said to use an exact answer, so we have to get the exact one. So here we go. So to use the quadratic formula, we need the a value. A value is 1. B value is 11. And C value is 8. And so over here, we have the a, b, and c, and we have to plug it into this quadratic formula. And so let's go ahead and plug it in. So we have negative 11 plus or minus b squared. Okay, so that's going to be 11 squared. And then we have minus 4ac, so minus 4 times a, which is 1, times c, which is 8. And all over 2 times 1. All right, now we can simplify this ugly mess. And, to simplify, I'm going to go ahead and use this calculator here. Again, this one is the directions to get this are in the open announcements at the beginning of the course. And it's free from the TI website. And so let's go ahead. And it might not work on Macs, just to beware. All right, so 11 squared. I'm going to simplify the inside of the square root first. Minus 4 times 1 times 8. Now we get 89 on the inside of the square root. So negative 11 plus or minus root 89 all over 2. All right. And so from here, the good news is 89 here. Now, typically, this is a separate question. Typically, say you have something like square root of 50. Something like square root of 50 can be broken up into 25 times 2. And the square root of 25 is 5, so that would be the same thing as 5 root 2. But the thing is, 89 does not have any perfect squares as factors, so you don't have to do anything. So we're actually done here. So let's go over here to the testing part here, my math lab window, and try to figure out how to put this in. So let's see here. Now this is a fraction, so make sure we start out with let's click in there, start out with the fraction. And let's see here. Negative 11. Now, I don't see a plus or minus sign, so it looks like we're going to have to put the answers separate. So, plus square root 89 over 2. And then, let's see here. Type in exact answer, use radicals needed, use a comma to separate answers as needed. So, comma. So, let's make sure we do comma. Do they have a comma in here? No, we'll just use a comma on the keyboard. Unless I'm mistaken, just make double check. No, I don't see a comma, so here we go. And then we have negative 11 again. And this time it's minus, and then square root 89, and that's over 2. All right, so we have the answers there, separated by a comma, and these are exact values using the radicals as needed. All right, so that's solving this equation, solving that quadratic equation. Here we go. Let's take out the next one, next example here. All right, so this question here says, all right, so we have an f of x, we have a g of x, and we're going to end up going through, and it looks like we're working on some composition of functions. So the first one says f of g of x. Well, what exactly does that mean? F of g of x. What that means is we're going to take this g of x and we're going to put that in place of the x in f of x. Because the g of x is listed second. It's kind of like writing it like this. F of g of x. So we're going to put the entire equation of g of x where we see x in the first one. And so this particular one, I have a 1 minus for f of x. So we got to be careful of the negative sign. Because when we put this whole thing here, with 3x squared plus x plus 2, in place of the x in the first one, we have to remember to distribute that minus sign. So let's go through it. And let's see here. So that's going to end up being 1 minus, I'm going to put a parenthesis here to substitute in, because that'll help us see that we have to distribute that negative sign. And plus x plus 2. And we distribute that negative sign to get, let's see here, so 1 minus, so it's going to be, I'm going to start writing it in order here. So minus 3x squared, negative and a positive, make it minus x, and negative 2, all right, so that's going to be negative 2. Now, that negative 2 here can combine with this 1. And so negative 2 and 1 ends up to make that minus 1. And so just to reiterate what we just did there is because we're substituting in, this minus sign applies to the whole g of x. So that's got to go in to all 3 pieces there. So a lot of the students will only put it into the first one. And so here is the first answer. So let's input that really quickly. Let's see here. So we have negative 3x. Use the exponent button here. 2 minus x minus 1. Okay. And now it's asking us to do just the opposite. G of f of x. And so what that means is so we have 1 minus x is f of x. So wherever I see x in the g of x, I have to put that in its place. This one might be a little bit longer because I see a square and I'm going to have to FOIL. So B is going to ask us to do just the opposite. All right, g of f of x. Let's make another darker color than that. That doesn't look as easily visible. All right, so for this particular one again, we have 1 minus x is f of x. Now again, this is just an example question. Yours, the numbers will most likely, I know they will change, but they'll be very similar question. Just numbers will change. So let's go here. We have 3, and then we have 1 minus x, and that's going to be squared, and that's going to be plus 1 minus x, and then plus 2. And so it's always a good habit to substitute in with parentheses because this one here, that one, we're going to have to actually FOIL it. So we have to FOIL that. And so let's do that on the side here. Let's do it on the side. So that squared means we have 2 of them. All right, and FOILing that gets us, let's see here. So we got 1 times 1, which is 1. 1 times negative x. Negative x times 1. And negative x times negative x ends up to be positive x squared. All right, positive x squared. So from here, we can actually, we have this 3 in front. Can't forget about the 3. So what we're going to do is that 3 is going to just distribute it into that whole piece that we just did there. So let's write it completely out here. So we have the 3, 1 minus, that 2 middle terms will combine to be negative 2x plus x squared. And we'll write it in the standard form, or the ascending, actually I think it's called descending order, standard form, after we simplify. Okay. So we're going to distribute that 3 into everything. We're going to get 3 minus 6x plus 3x squared. And now, because there's only a plus sign here and nothing to distribute, that's going to just remain as is. And now, we're going to combine like terms. And so, let's see here. We have the positive 3. So we have positive 3. We have positive 1. And we have positive 2. So 3, 1, and 2, that gives us 6. So that's going to be plus 6. All right. Let's clear it up a little bit here. All right, so we know it's going to be plus 6 at the end. And let's look at the x's now. So over here we got minus 6x, key as it's minus, and minus 1. So that's going to be a minus 7x. And then last but not least, we have the 3x squared. And let's see here. Let's just make sure. We did use that 3. We did use that. We used that. We did the 1 with the 3 and the 2. All right, so we used everything. Good to go. So 3x squared minus 7x plus 6. So 3x, use the little square thing, squared minus 7x plus 6. All right, so that one was the third question. Let's go next. All right, so for part C, this one says f of g of 2. So that's really just plugging 2 into what we did in part A. So over here, we're just basically plugging in 2 to what we did right there. So let's plug in the 2. So negative 3 times 2 squared minus 2 minus 1. And so that ends up to be 2 squared is 4, and 4 times negative 3 is negative 12, minus 2 minus 1. Negative 12, negative 2, negative 14, negative 15. So we have negative 15 here. Negative 15. And now the next thing is we're going to plug in 2 to the thing we did for part B. So let's take a look at part B here. So again, we're going to plug basically 2 into this, and it's going to be 3 times 2 squared minus 7 times 2 plus 6. And so we have 2 times 2 is 4, times 3 is 12 over here, and that's minus 14 and plus 6, and negative 2, and combines to be 4. All right, we're rolling now. So here we have this polynomial, and what we're going to do is we're going to use the rational zero theorem to find all the possible zeros. Now this doesn't mean that a zero is going to occur at every one of them. It's just a possibility. And so to do that, we look at the factors of the leading coefficient and the constant. This one ends up to be pretty easy. So since it's 5, they both are the same. So the only factors are 1 and 5. So those are the only factors of both of them. But you have to make sure we have to take into account all the possibilities now. So those are the factors that we're going to work with. And typically the textbook and some notes will say, they'll use the letters P and Q. And typically I think the leading coefficient they have is Q and the constant is P. And so basically it's going to be the factors, all the pluses and minuses. And we have to list out all the possibilities when it's P over Q. And well, we don't really have all that many because again, plus or minus, we have 1, 5. So technically we have, one more time, we have negative 5, negative 1, 1, and positive 5. And so those are things that we can look at. So here we go. But we can still shorthand it as, plus or minus. We don't have to list them all out like that. So let's go ahead and pair them up. So the P here, the possibilities for P are 1 and 5, and the possibilities for Q are also 1 and 5. So like I said, this one ends up to be a little easier. So here we go. So this ends up to being, let's look at some possibilities here. So we have plus or minus the 5 over 1. And then plus or minus, then the next one would be plus or minus the 5 paired up with the 5 now on the other side. Okay, and now, so now we look at the ones. So over here, it will be plus or minus 1 paired with the 1, and then plus or minus the 1 paired with the 5. And now, as we go to simplify this, some of the solutions are going to end up being the same, so, or possibilities the same. So here we go. So the first one is just plus or minus 5. The middle two end up to be plus or minus 1. So we really don't have to write it more than once. So plus or minus 1. And last one is plus or minus 1 over 5. All right, so those are just simply the possibilities. And now let's look over here. List all the rational possible. All right. It says type an integer or a simplified fraction. Use a comma. All right, so we actually have to write these all out. So let's write them all out here. So it would be -5, and then separated by comma, comma, and be +5, and then -1, and then 1, and then, oh, we want to make sure we use a fraction side here. So -1 or 5, whoops, and then comma, and we have 1 over 5. And so there's your possibilities. And now the next part says use synthetic division to test several possible rational zeros in order to identify one actual zero. Okay, so one rational zero for the given function is, and it says simplify your answer. All right, so over here, let's test one of the points here. Now I'm going to show you one that does not work. I'm going to show you one that works. Well, there's actually only one that does, but let's take a look here. So if I use the 1, so let's use synthetic division, and so I'll use 1 here. Now technically, if you look at this here is x equals -1. And so to use synthetic division, you have to remember, we end up doing the opposite over here. So that's going to be +1 over here. And so let's put the 5, 27, 11, and 5. All right, bring down the 5. 1 times 5 is 5. Add those together, we get 32. Multiply, we got 32. Those together ends up to be 33. Oh, 43. 43. And then 143 is 43 over here. And then over, last but not least, 48. So if this last thing here is anything but 0, there's a remainder, which means that is not a possibility. Not a possibility. So now let's look at the one that is the possibility, or is the 0, I should say. And that was going to be, let's see here, pretty sure -5. So let's look at -5. And just to clarify one more time, before if you had a factor, say x plus 1, and you were testing to see if that was a factor, then you would put the opposite. So that was one mistake I had. So I just want to clarify, it wasn't necessarily a mistake. But the 1 here, if it did work, that 1 is actually going to be one of your zeros. And so I'm testing -5 now, so we're going to bring down that 5. And if this works, instead of having a remainder here, it'd be 0. So let's see if it works. And I almost made a goof again. Let's just put a 5 there. -5 times 5 is -25. And so from here, add those, we get 2. And then that's going to be -10. That ends up to be 1, -5. Oh, sweet, there we go. 0. So my remainder is 0. Which means this -5 here, so that is one of my possible zeros. And so, so over here, I'm going to put -5. And I'll use the 0 from part B to find all the zeros of the polynomial function. It says simplify your answer. Use a comma to separate integers as needed. Type an integer or a decimal rounded to 3 decimal places as needed. So let's take a look here. This here ends up to be 5x squared plus 2x plus 1. And a quick test to see if this here is factorable or has zeros, let's go to the graph. And let's go to the graph here. Let's see here, we have 5x squared plus 2x plus 1. So let's type that in. 5x squared plus 2x plus 1. All right, let's just make sure. Good to go. And oh, look at that. As we scroll in here, something pretty unique happens here. It doesn't actually cross the x-axis. And since that does not cross the x-axis, it doesn't have any more zeros. So this here is not factorable, and this has no roots, which means this, yes, there's two imaginary roots, imaginary numbers. So this here says the real zeros. So this one only has 1. And if we actually go and graph the original, like I think I had up there, 5x to the third power plus 27x squared plus 11x plus 5. Let's scroll out here, and if we look here, this graph does end up only intersecting once, which means it only actually has 1 0. So from over here it says use the 0 from part B to find all the zeros of polynomial. Well, the thing is we only have one, just a -5. Now, if this ends up to be factorable, or if you graph it and crosses the axis, that means you have more than 1 0. So you have to go back and find the other zeros, or the real zeros. So again, if that graph, after we simplified it to this, as we graphed it, if it crossed more than once again, or even once, there's going to be another 0 in there. But it didn't cross, and we verified with the original graph it only crosses once. So this one actually have 1 0. All right, and let's go to the next. All right, so this next problem says solve the polynomial inequality and graph the solution set on a real number line. Now this one is going to be very, very helpful to do a graph. Very helpful. And so I'm going to show you. And the graph actually pretty much gives away the answer. So let's take a look at this here. So we have 7x is less than 6 minus 3x squared. Now I'm going to show you how to get the numbers, just because it's good to know where it comes from. So we're going to get this to 0. We're going to bring everything to that side. So it's going to end up being positive 3x squared. And then it's going to be plus 7x. And then minus 6. And that's going to be less than or equal to 0. And now, well, you have to sometimes strategize. And one good way to strategize is to take a look at some of these zeros they have here. -3, 2/3, -3, positive 2/3, -2, 1. For the most part, they have the -3 and 2/3 in 3 of the answers. That might be giving it away completely on how to factor this guy here. But to factor it, there's so many different ways, so many ways. We can use the AC method. You can do trial and error. But let's try trial and error. So that actually seems kind of pretty easy because we have a 3x here. So we have 3x and x. All right, so if we take a look here, the majority of these guys have a 3 and a 2/3. So let's think about what that means. So in order to be -3, that means this guy over here had to be +3. Because if you think about it, x plus 3 equals 0, x would equal -3. And so -3 was the most common one there. And this might work, it might not work, but we're going to verify in a second. And so this one here said 2/3. So 2/3. Well, so that's going to end up being -2 over here. So let's think about that here. 3x squared minus 2 equals 0. First thing, you would add the 2 to each side to get 3x equals 2. Divide by 3. And x equals 2/3. So if they're giving you possibilities, why not try those possibilities? And this one worked. And so here we go. We have our parentheses. And, well, I was actually going to show you that exact thing. So let's bring that back up. And then we have, oh, sometimes I wonder about myself. And then x plus 3 equals 0. And x equals -3. All right, let's just verify real quick. 3x times x is 3x squared. 3x times 3 is 9. 2 times x is minus 2x. So 9 and minus 2 give me the positive 7. Negative 2 times positive 3 gives me the negative 6. So we're good. So those actually worked. So these are the possible zeros. So the question is it going to be shaded going outside, going inside? So let's take a look here. Well, first off, it says less than or equal to. It says less than or equal to. So if you take a look, we can start eliminating some things. Well, first off, we can eliminate B. And F since it's blank. And also E since it's negative 2 and 1. So it's got to be A, C, or D. Now, since it has, again, going back to the equal to part, we just got to have a bracket, not a parenthesis. So C has parentheses. So that one is eh. So we're down to A or D. Down to A or D. And so down to A or D. Well, let's see here. That one's shaded in. That one's shaded out. So what to do? Well, this graphic calculator will actually help you. If you type it in here, this is Desmos.com. And you can see the zeros are right there. And it's shaded in the middle. Shaded in the middle. Okay, so that basically gives it away. It's going to be A. But if you didn't know how to do that and you weren't sure, you don't like using that graphic calculator, that's okay. Let's use a test point. 0 is the easiest test point. So let's plug in 0. So if we plug in 0, let's see what happens. So 7 times 0 is that less than or equal to 6 minus 3 times 0. Well, let's see. First one over here on our left side would be 0. And 6 minus, well, 3 times 0 is 0, so that's going to be 6. So the question is 0 less than or equal to 6? The answer is yes, that works. And if you notice here in part D, 0 is now part of the shaded region. But in part A, it is. So we're good. It's got to be A. But let's make sure here. Let's see here. What is the solution? The solution set is, and it says do that in interval notation. To have an exact, using radicals if needed, integers. Okay, so let's do interval notation. So negative 3 to 2/3. So we need brackets. Let's see here. So let's see if they had brackets in here to use, because they would probably prefer that. But I'm not seeing brackets, so I'm going to use the keyboard. All right, keyboard brackets are near the P. All right. I'm hoping that that's what it uses. So let's see, negative 3, and then it says comma, and then fraction 2 over 3. And then another bracket. There we go. All right, so that's interval notation saying going from negative 3 to 2 over 3, which matches A. All right, let's keep motoring. All right, so this next one here, next one is graph the solution set of these system of inequalities. Now, this one is definitely easy and really great to use this utility over here. So y is greater than 2x minus 10. So that's the first one. So that one's dotted, as it has one's a dotted line shaded above it, which you got greater than. Next one, we have y is less than, and that's going to be x minus 2. All right. Oh, they both showed up as red. Huh. That's unusual. But anyways, so over here, we have a common solution area is right in here. Common solution area is right in here. Oh, one's a little darker, one's a little lighter. I see what they did. But the darkest region is where they're shaded together. And so that's actually our solution. And so that's, we just have to duplicate this on the graph. So let's go ahead and duplicate it. Let's look at this one here. So we have an intercept here at 0, negative 2. That's the second graph here. And what else? We're going to need another good point. Oh, that's another great point right there. 0, negative 2, and 2, 0. Sweet. So let's enlarge this graph. And the first point is, select the tool. You have to have a line, -2, +2, but that's got to be dashed because it's not included. It doesn't have the equal to part, so it's got to be dashed. And let's get the next one here. What are some good points here? 5. Oh, it's always really good, especially if they have the intercepts. That made that real easy. All right, so let's go over here. -10 and +5 is right there. And this one again is a dotted line, so we're good. It is dotted because again, it has the less than, but doesn't have the equal to part. So from here, we need to make sure we shade. So that's a shade tool, and that's going to be shaded right there. And that's the shaded region. That's the solution region, and we are done. All right, so here we go. Next. So for this one here, it says use the given conditions. You're going to write a system of equations again. So let's think about that. System of equations. So we have the sum of two numbers is 10. Okay. So the two numbers would be x and y, which is perfectly fine. X plus y. And now you don't have to be all formal and write let statements. I mean, you're doing the work on the side. So x plus y is 10. Okay, now the next part says if one number is subtracted from the other, the result is 2. So if x is subtracted by y, the result is 2. Okay, so from here there's so many different ways you can solve this. So many different ways. You have elimination, you have substitution, you have graphing, you have matrices. This one here is very easily set up as elimination. So let's just go with it. So I can add these two equations together, and that actually gets rid of the y. X and x give me 2x. Y's cancel and equals 12. Alright, and so 5 by 2. You get x equals 6. Now you can plug that back in. It doesn't matter which one. Just plug it back into either one, and you have to see what we get. So we have, I'm going to do the first one. 6 plus y equals 10. Subtract the 6, and you get y is 4. So there are two numbers, 4 and 6. And it makes sense. You put them both together, 4 and 6, and you get 10. You subtract them, and you get 2. So let's see, it says use a comma to separate the answers. So we have 4, comma, 6. Here we go. So this one here says solve the system by addition method. Now again, there's nothing specific here to say, hey, you have to actually do it that way. But let's go through step by step for it. All right, so I'm going to actually go through and just do the addition method. So we're going to eliminate one of these variables. Doesn't matter which one. No, it really doesn't matter. You can eliminate the y's because one's negative, one's positive already. But we're going to have to multiply both equations by a value to get the numbers to match. So I'm just going to pick the y's because I did the x's first last time. So to get the 4 and 5 to match, we want them to be 20. So I have to multiply that top equation by 5. Let's multiply the bottom equation by 4. And so the result's going to be 10x minus 20y equals, and one of the big mistakes that students make is they do not multiply the 5 with the negative 14. You have to do that. So here, let's do a little bit. 5 times 14, bam, 70. So minus 70. And the bottom will be 12x. And there's plus 20. Now those numbers match, so we're going to be able to eliminate the y's. And 4 times 12 will give you 48. Alright, so now from here, we can add those two equations, because that'll eliminate the negative 20 and positive 20. 10 and 12 is 22. 22x. And that's going to equal, well, let's see here, negative 70 and 48. Of course, conveniently, that's going to end up being negative 22. And just to so you guys can see it, 70 negative plus 48 negative 22. So divide by 22 and we get negative 1. Alright, so we get the x value. Now we have to plug that back in to get the y value. So plug negative 1 in. Doesn't matter which one. Nope. I'll use the second one this time. Alright. So that's going to end up being negative 3. Alright, we're going to add that 3 to both sides. And we get 5y equals 15. And then we're going to have to just simply divide by 5. And so we end up with y equals 3. Alright, so the solution set is type an ordered pair. Okay, so the ordered pair is going to be negative 1, comma, 3. And so it'd be negative 1. Oh, there we go, comma, 3. Oh, where's my parentheses? There it is. Alright, good to go. So this one definitely has a solution. Another way to check it is our lovely handy dandy graphic calculator here. So let's put it in just as we see it. 2x minus 4y equals, I'll get that side right one of these days, 14. And next one is 3x plus 5y equals 12. And let's get rid of those points and look at the intersection point. There's the intersection point at negative 3, comma 1. Beautiful, great graphic utility to help us out with this stuff. So, in this one here, this one says solve the system by substitution method. Again, you actually don't have to do that. You can go right to the graphic utility here, and I'm going to graph it for you. So 5x, let's get the actual x in there, plus 9y equals negative 4. And then we have 3x minus y equals positive 4. And so let's just verify 5x plus 9y negative 4. Alright, and there you go. Our solution is going to end up being 1, negative 1. But I'm going to show you how to do the substitution just in case. Alright, so substitution. I have to somehow get one of the variables by itself. And it looks like the second equation is going to be easier. So let's look at that second equation. I subtract the 3x from each side. And negative y equals negative 3x plus 4. Now, a lot of students will see that negative in front of the y, completely drop it off and not do anything with it. You technically have to divide everything by negative. So that's going to be y equals 3x minus 4. Okay, so now I have y by itself. And right now what I can do is, since I have y by itself like that, I can take that and put it in place of the y there. And so what that'll do, that's called substitution. So we have 5x plus 9 times 3x minus 4 equals negative 4. And let's distribute that 9. So if we go to distribute that 9, we end up with, let's see here, 27x, and then that's going to be minus 36. All right, and so let's just keep going here. So we have that negative 36, then we can bring that to the side by adding. So if we add 36 to each side, and then we also put the 5x and 27x together. So 5x and 27x give me 32x. If I add that to both sides there, so what happens now is negative 4 and 36, well that gives me 32. And divide by 32 and we get x equals 1. And then we can substitute that back in to either equation, doesn't matter. We'll just use the second one this time. 3 times 1 minus y equals 4. Right? Okay. And 3 times 1 is 3, so basically I'm just going to end up subtracting 3. And I get negative y equals, and that's going to be positive 1, but then I get divide by the negative and get y is negative 1. And so there's my ordered pair, 1 comma negative 1. Just the same exact thing I got over here. And so here we go. Ordered pair is going to be parenthesis 1 comma and then negative 1. Oops, I did a subscript. Oop. Okay. 1. There we go. And close parenthesis. Alright. Oh, don't want to forget the negative sign. There it is. Negative sign. Good to go.